Hello, this is Ivailo Enev. I'm a graduate student at FAU, and I'm taking the analysis of algorithm class. This is my project demo. So this is the code over here that we have for the project, and let's run this real quick. It doesn't take too long, but still, while it is compiling, I can go over my codes. The first part is just a simple calculation to calculate what is the distance. It uses NP SQRT, so nothing fancy. Then we calculate the brute force algorithm pretty easily where we're iterating through the points. Then there's a separate function for the merge sort that we need in order to then fit into the divide and conquer algorithm that we use afterwards. This is just the merge function that we need in order to sort by X or Y coordinates. So if X is true, then it goes through this if, and then it sorts by the X coordinates. And then again, if X is not shown, then it goes through the else statements and it sorts by the Y coordinates that you can see over here. Then again, we have the closest pair, which is the calculation, and this is more or less the meat of the divide and conquer, which again follows the premise of divide and conquer and how it's calculated here, where we split the different problems into two separate problems, and then it goes recursively through the points again. And in that edge case, we need to do a strip where we use the py, which is it's sorted by the y coordinates, and we only need to look at the 15 points ahead of each point to be able to calculate if there is another closest pair that will apply otherwise. And then finally, we have the divide and conquer, which combines everything so far. We have a pretty simple function where we specify how many points we want, and we assign pretty big values for x max and y max. Then what it does is that it creates on a random, it creates all the points. And then in order to convert that into, I'm sorry, in order to convert that to xy coordinates, we just do this function, which essentially it divides, and then whatever is the remainder is taken as the y value. So pretty simple version for us to get xy coordinates. Then once we're going through the actual implementation of the algorithms, I'm using pretty simple points. For them, we have to first assign those first points, then we calculate the time for the brute force algorithm. Then using the same points, we use the divide and conquer algorithm. And then each time is then saved into a table format that we can see over here based on N and J, which is I guess I don't have that, the table necessarily. So I apologize for that. Let me real quick show the. So this is what the table format looks like. So we have 10 iterations, and then we have all the different points. And what we do in the following code over here is we just take the average of all 10 different tests that we did for each different input size to then find average again. We then fill out this table over here, which finds what was the empirical running time. Then using the theoretical running time, we can find what is the ratio. And then using the ratio, we can find what the predicted running time was supposed to be. We applied the same thing for the divide and conquer, and this one was for the brute force algorithm. This is just a simple function that helps us make the charts a little bit more neat. Here we have the empirical performance for both algorithms. Algorithm 1 is the brute force, and algorithm 2 is the divide and conquer. We can see the different growth that is pretty much aligned with what we were expecting. And we can see this exact performance, the empirical versus predicted performance. This is for algorithm 1, which is the brute force algorithm. And we can see the empirical time runs pretty much similarly, just slightly below the predicted running time, which is to be expected. And this is for the divide and conquer, which is linear logarithmic running time growth. So this is it. Thank you.